Good morning everybody. We have lined up a ATS intelligent version with an L controller for today's demonstration. The ATS is connected with generator as source 2 and EB supply as source 1, and the output is connected onto a meter where we can see the output. Although we do not have any load right now connected onto ATS, but typically all other functions we can take you through. We will start with a simple demonstration where we have source 1 and source 2 both are initiated, and the ATS is in the auto mode, which can be changed into manual through this switch. This is manual and this is auto. The moment ATS is in auto mode, you can see a LED indicating auto switches on. We have another 4 LEDs which is indicating the source levels. If the source 1 energy is on, then we have first AC LED going on, and if the source 2 energy is on, then we have the second LED glowing on. When we have these 2 LEDs on, it typically signifies that both the sources are healthy and are available at the input. Typically at this moment we have source 1 and source 2 both energized, and the ATS is in source 1, mainly because we have selected the priority as source 1. Meaning if your EB supplies are connected to source 1 and the generator supply is connected to source 2, then always it takes the priority as EB, and whenever EB fails, it sends a signal to generator to switch on, and when the generator supply is available at the terminals, it switches to source 2. And when the EB comes back, it comes back to EB level as source 1, which is also known as auto recovery. So we will simulate a condition where the EB supply fails. We are now switching off source 1 EB supply. So the ATS senses that there is a failure of EB. Since the generator supply is available, it moves into generator mode. This is a simple function of auto transfer. Let's now understand how our auto recovery works. Let's assume that the EB has come back. So I'm switching on the EB supply. The moment EB supply is on, the ATS recognizes that the supply is available at the source 1 terminal, so it comes back to source 1. So thus complying to the fact of auto recovery. Let's go back to typically back to the same function where we have all the energies are available, both source 1 and source 2. Now I am now simulating first fault, which is a B phase failure. So when a B phase fails, likewise I told you earlier, the ATS moves into source 2 as the energy is available. And now please give attention to this fact. Now already there is a fault available. Now I am simulating a fault which is of phase sequence or another voltage failure in the generator. So this is the second fault, which is a voltage failure in the generator. So technically what should happen? You should move into a 0 position. So ATS moves into 0 position. It cannot go into source 1 because the source 1 has a fault already. It can't move to source 2 because source 2 also has a fault. Now let's assume now source 1, that is EB, comes back, pitches back. So I'm switching on the Y phase of EB, so goes into EB mode. So what we are trying to tell you here is the controller has ability to take subsequent faults, not only one fault. It can take 1, 2, 3 faults and similar, and it can function as it is logically programmed. Also, I would like to take you on to a phase sequence fault. Typically now we have EB fail, generator is available, so it moves into source 2. Now I am trying to see if the phase sequence fails. I am sure you all understand what is a phase sequence fault. I try to move into phase sequence fault. All 3 phases are available, but the phases have flipped. So it recognizes that and goes into an off mode. So this is another feature which is again, this is an optional feature. Only when you want it, you will have to predefine it to us. So material before getting dispatched, we will enable that feature and dispatch it. So when the phase sequence is back to normalcy, then switch moves into source 2 position. So I will now take you to a under voltage protection which is inbuilt in the ATS. ATS is in source 1. We have a auto transformer where we can reduce and increase the voltage. Typically 230 is the phase voltage. I'm taking it down now, let's say 160 volts, for where the threshold level of the under voltage is now programmed for 160 volts. Okay, 58 volts, when under voltage is simulated, switch identifies that, goes to zero, is available in generator, moves into generator. Now let's assume that the voltage comes back to, now voltage we have increased the threshold level for voltage to recover back is about 180 volts. So we are at about 180 volts. ATS switches back to normal operations. So that's about under voltage. Similarly, we have the same system for over voltage. Now the voltage goes beyond 300 volts. Beyond, we have right now we have set the value at 270 volts. So the voltage is at 279. So 279 higher voltage, it recognizes that and gets into generator mode or the off mode. So the whole ATS is now tested and programmed to operate at about 310 volts. So every device, every three-phase device is actually tested at 310 volts. So in an event of temporary, let's assume a neutral failure of elsewhere, if the line voltages are going to go high, it can actually, to some extent handle that kind of a situation. Apart from this, the biggest feature what we have is first neutral close and last neutral open is a built-in feature with the ATS as. Probably Dilip will explain you when it comes. Thank you.